Hello everyone, and welcome to the AI Research Roundup. I am Alex, your host, and today is May 8th, 2025. We are looking at a research paper from Hugging Face's trending list, published about 9 days ago on April 29th, titled XCross, Dynamic Integration of Language Models for Cross-Domain Sequential Recommendation. This paper introduces XCross, a system to help recommendation AIs quickly learn new product areas with little data. It works by integrating several language models, each fine-tuned using low-rank adapters, or LoRA. LoRA is a parameter-efficient fine-tuning technique, a smart way to update AI models with minimal changes, making them very adaptable. Alright, so we have these low-rank adapters, which we talked about, making the models adaptable. This figure here, figure 1, shows us an example of a sequential recommendation prompt. This is essentially the input given to the XCross system. You can see it has a history section, listing items a user previously interacted with, like an emergency shovel and a survival whistle. Then, there's a candidate item, which is what the system might suggest next. In this example, it is emergency thermal blankets. The core idea of sequential recommendation is to predict the next item in a user's sequence, and XCross tackles this by scoring how well this candidate item fits the given history. Okay, so following that prompt we just saw, this next diagram, figure 2, lays out the XCross model architecture. You can see the prompt feeds into a series of model blocks. Each block contains several transformer layers, which are powerful components in language models for understanding sequences. The real magic happens with the XCross integrator shown between these blocks, and also detailed on the right. This integrator dynamically combines information from different models by using their activations, essentially the signals or outputs from their layers. This integration is what allows XCross to adapt across different product domains efficiently. Alright, so that XCross integrator is key for combining knowledge from different models. Now, to really see how XCross performs, this table, Table 1, lays out the dataset statistics. It shows various, quote, target domains like electronics and sports, listing the number of users, items, and interactions. It also specifies the, quote, source domains used for learning. You will also notice a data density figure, which essentially indicates how much interaction data is available for each domain relative to all possible user-item interactions. These details are important for understanding how XCross adapts, especially in areas with sparse data. Building on those dataset details, Figure 3 now visualizes the accuracy. The metric used here is hit at 1. This measures how often the single top-ranked item recommended by the system is actually the item the user was interested in. These plots compare XCross against just using low-rank adapters across different sample sizes for domains like tools, sports, toys, and electronics. We can see XCross, represented by the blue line, generally achieves higher accuracy than the green LoRA line, especially when the sample size or the amount of training data is small. This really highlights XCross's efficiency with limited data. So, as those accuracy plots vividly showed, XCross excels with limited data. Wrapping up, its key strength is efficiently adapting recommendation AI to new domains. It achieves this by dynamically integrating specialized models, tuned with low-rank adapters, leading to good performance with less data and compute. The paper confirms this using metrics like mean reciprocal rank, or MRR. Another way to measure ranking quality and ablation studies, tests showing which parts are essential, highlighting that dynamic integration is crucial. That is all for this AI Research Roundup. Thanks for tuning in.